Hello, so today we are going to do the third problem from Leetcode 30-day challenge, maximum subarray. So the problem says, given an array of numbers, find the contiguous subarray containing at least one number, which has the largest sum and return its sum. So we want to, given an array, we want to find the contiguous subarray that has at least one number, which has the largest sum and return its sum. Okay, so for example, this array here, if we take 4 minus 1 to 1, that's the largest sum you can obtain in this array, right? And contiguous means there shouldn't be any gaps in the numbers, right? So, well, definitely we can do this in a brute force way, right? Because we could just try all the subarrays, contiguous subarrays, and see which one has the largest sum. But here in the follow-up section, it says, if you figured out the overall solution, try coding another solution using the divide and conquer approach, which is more subtle. So the divide and conquer approach. I remember this related to a Caden algorithm where you just keep the current running sum and you keep the maximum sum so far. And for every element, right? So basically, if we think about it, we have two choices: either start a new contiguous array or keep the one we had so far, right? Let's first write so they said, okay, figure out the O(n) solution. The one that I was thinking about, the brute force one, is not even O(n), it's O(n) squared, right? So let's try first to figure out O(n) solution and then try to figure out this divide and conquer approach. So how can we do? So if we have, so what we want, let's just think here about what we want. So we have this array. So we could have max so far, right? And then we could have the current max, right? Let's call it this. Current max. Right? And then we could, I guess the main point here that is making me hesitate a little bit is that, like, for each number we have two choices, right? So for each number we can continue the current contiguous array, max so far, current, let's say current sum or something. The current sum, start a new sum, right? And so if we, let's say here, start out with -2, when do we decide to not include -2 and just start from 1, right? Okay, I think we could just basically pick the biggest of each every time, like just pick the largest. That would definitely give us what we need, yeah. So what I'm thinking here is, okay, let's initialize both. So we need max so far, or let's say best sum. Let's give it the name best sum, and then let's say current sum, right? So both start out as, so the best sum needs to start out as, because maybe the best sum is 0, right? Not taking any number in case of an array of only negative numbers, right? And then the current sum, let's start with 0, and then let's just go through it. So the current sum is we definitely know that best sum is equal to the max of the best sum so far and the current sum, right? Now the current sum can be just the max of 0 and the current sum plus the number. Okay, it's always better to not take. It's always better to just not take anything if the sum is going to be less than 0, right? Which would save us from taking -2 here. And then here we could just return the best sum, right? There is one problem, which is what if the array is empty? At that point we should return 0, so let's just say max. Because 0 means I'm just not taking anything. Like with an array that has empty numbers, let's say -1, -2. Well, it's better to just not take any number. So let's try to run this. Okay, so it works for that one. Let's give an empty array, give an array with one number, an array with only negative numbers, an array with positive numbers. Let's run this. We have a problem here. This is the expected answer. So actually, they don't expect 0, weirdly. They expect just the negative number. So it seems like the problem says, basically, just give the, okay, I mean, we could do that. Just give the best sum even if it's a negative number. And if you can't find anything, it seems like they want the minus infinity. You know what? I'm actually going to try to submit this because, yeah, they expect at least a non-empty contiguous subarrays. That's what the problem should have said. So, I mean, we could. We could start here with so let's just say num0, right? And this is if nums, else. Yeah, because best sum will be 0, right? Yeah. So basically this 0 here won't work for us, right? Because maybe we can do current sum here, but that doesn't really justify. Okay, so I think what I should do here is, instead of doing this, let's just the current sum, let's add the number right away. And then let's not do the max before. So let's pick the maximum here so that we can get these minus values. And then for the current sum, let's just pick, if it's became less than 0, let's just restart basically. And here we could just return this sum. Okay, looks good. There is that infinity, but I think it should be fine. Okay, so that's accepted. Let's see if there is something else here. So essentially here, let me just first explain what I'm doing. So I'm keeping the current best sum, which is the current max, which is the maximum sum we found so far, and then the current sum of the array. And so every time I add, I check if it's the best sum so far. If it is, I put it here, and then I take the max between 0 and the current sum just to avoid having negative numbers, because that will mean my sum won't be the best one, like the current sum. Because, for example, if I take -2, when I get here, I don't want to keep -2, because if I keep it, no matter what sum I have, it won't be the best sum because of this negative value. So I can just take the max with 0 to kind of simulate the way that I'm starting a new contiguous subarray, right? And that's pretty much it. So let's see. Yeah, this is a really small portion here. Yeah, this is same thing, cadence algorithm. Same thing here. Yeah, I think it seems like yeah, most people did the seems like most people did the cadence algorithm implementation.